There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and thorium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discussed.
Welcome to the first part of our study of the periodic table. For this part, we are going to have these objectives. First, we're going to explain how and why elements are organized in the periodic table. Next, we're going to look at the first periodic table and compare it to a modern one that is in use today. Look at some of the suggestions for making the periodic table more user-friendly. There are some that have said that the periodic table is very difficult to understand. We're going to look at three broad classes of elements and how we identify those and some of the characteristics of each of them. And last, we're going to look at the elements that are classified as gases at room temperature and learn how to identify those using the periodic table.
These are the elements.
The periodic table.
These are the elements. These are the elements.
In order. So we got hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, and oxygen, fluorine. Now stop snoring. This isn't boring, and this is stuff you shouldn't be ignoring. Neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine.
They were up to 17.
You never had it better for remembering the elements.
These are the elements. These are the elements. These are the elements. These are the elements.
So then we got argon, potassium and calcium, scandium, titanium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, and bromine. That's under chlorine and fluorine. Just keep snoring the order for your motorboard. Krypton, rubidium and strontium, yttrium, zirconium, niobium, molybdenum, technetium,
Radioactive.
rhodium, palladium, silver, cadmium and indium, tin, antimony, tellurium, and iodine.
These are the elements. These are the elements.
That's 53, y'all.
These are the elements.
Sitting under bromine.
These are the elements.
So now, cesium and barium,
Lanthanides.
lanthanum and cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, and terbium,
Going on.
lutetium, hafnium, and tantalum, osmium, iridium, platinum,
Bling.
gold,
bling bling,
mercury,
Hg,
thallium and lead, bismuth, polonium, astatine, radon,
cobalt.
francium and radium.
These are the elements. These are the elements.
It's getting hot,
Elements.
radioactive.
These are the elements.
So now we got the actinides, actinium and thorium, proactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, and fermium, mendeleum, francium.
That's it for the
Whoa,
actinides.
but we still got a little heavy metal to go. Rutherfordium, dubnium, seborgium, thorium, and hassium, meitnerium, darmstadtium, rutgentium, and now you all can sing it yourself, cause copernicium gets us to 112.
These are the elements. 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 These are the elements.
Start off with a little periodic table humor. By 1700, there were 13 known elements, and 13 is a relatively easy number to remember. But just a decade later, 5 additional elements, including 3 colorless gases, had been discovered and added to the knowledge base. So now we have 18, and it's getting a little bit difficult to remember these and their properties. As more elements were discovered, there arose the need to organize them into an easy form so that they could be used and remembered. The first means of organizing the known elements were by the observed properties. These were used to sort the elements into groups. In 1829, J.W. Dauberreimer established a system whereby the elements were grouped into triads, or a set of 3 elements with similar properties. Chlorine, bromine, iodine were grouped together because they have similar chemical properties. They're gases at room temperature, they have a color, and they reacted with certain metals.
In 1869, Dmitri Mendeleev illustrated recurring trends of the 80 elements that then were known. The Russians 6 feet under, but the list has grown. So if you'd rather hear the radio than teachers talk, listen to the periodic table of rock. It's gold. Gold 79 is gold. Lead minus lithium's gold. Zirconium plus yttrium's gold. 3 galliums and a carbon is gold. And carbon makes wood. Starting in the middle 48 is cadmium, playing second fiddle to its cousin thallium. Sum its valence numbers and you've got fluorine, which you should mix with 1. Triple that to 51 antimony, then tellurium, then iodine is 53, and gold. Gold 79 is gold. Beryllium plus rhenium's gold. 11 nitrogen plus helium's gold. Astatine minus carbon's a gold. Makes wood. Alright, so this is all the lanthanides. Numbers 57 to 71. Pencils out. Lanthium, cerium, erbium, thulium, terbium, holmium, europium, samarium, ytterbium, platinum, dysprosium, gandolganolium, neoneodyne, praseodymium. Hydrogen plus helium plus salts for with iron 26 it turns it green. Minus 10 to sulfur, now the whole thing stings. With an oxy, cobalt, nickel, silver, copper, and zinc. Calcium will stop your bones from growing old, but I'd trade my health away for just 1 mole of gold. Cause it's gold, gold, baby, gold, gold. AU stands for go, go. What better than platinum gold? I trade the carbon in my body for gold. And carbon makes wood.
Mendeleev arranged the elements in his periodic table according to an increase in atomic mass. He did this so that his students could understand and remember the elements better. What he did was he put all this information on cards and started to arrange them accordingly. He quickly realized that there were gaps in his table, so he left spaces for future elements. This is what his table looked like. Notice that there are gaps in there for the elements that he knew would be discovered later on. Now, his table has been rewritten for this so that it's easier to read and understand. The EKA elements, those are elements that he knew, but they hadn't been studied sufficiently to place them in some sort of order. But he also noticed that there was a pattern there that the elements would follow along. Currently, there's 118 recognized elements, 92 of which are naturally occurring, and the rest have been made in nuclear colliders and nuclear reactors. There's more being discovered almost every day. Well, not every day, but frequently. There is a theoretical limit as to how many elements can be discovered. Most of the more recent elements last only a fraction of a second and then decay, so it's been very difficult to study them and find out their properties. But we know that they are there from the way they react in the reactor. In the modern periodic table, the elements are arranged in an increasing atomic number, not mass, but atomic number, which changed the order that Mendeleev had come up with, but it still works. The term periodic comes from the Greek root words peri, meaning round, and hudos, meaning path. So it's a cycle, a constantly reoccurring cycle, and we see this when we look at the elements and their properties. This is the first half or left half of the modern periodic table. And this is the right half. Notice the different colors for the different squares. This indicates the type of element that it is. Now, there are some people that say the periodic table as we have it today is very user unfriendly, very difficult to understand. And so they have proposed some new forms of the periodic table. And I'd like to take a couple minutes and show you some of those. Now this particular one attempts to put the periodic table in a three-dimensional form. This one is called the galaxy of elements. Now let's look at three classes of elements. We're going to look at the metals, nonmetals, and metalloids. First, let's look at the metals. Most of the elements are classified as metals. You can see this if you will review the video that we started out with. Metals have the following characteristics. First, they are very good conductors of heat and electrical current. Second, they have a high luster, or they're shiny. Now we're talking about the pure metals, not the metals that have combined with oxygen. Solids at room temperature. They are solids at room temperature. One exception is mercury. Mercury is classified as a metal. It has a high luster. It's a good conductor. That's why they use it in thermostats. But it is a liquid. Metals are ductile, which means they can be drawn into wires. And they're malleable, which means they can be hammered into thin sheets. Just like people used to use gold over statues and temples, they'd hammer the gold into very thin sheets and then tap it into place. Nonmetals. Nonmetals are located in the upper right-hand corner of the periodic table. And they show the greatest variety of properties, unlike metals or metalloids. Most of them are gases at room temperatures, and we'll take a look at that in just a minute. They do have the following properties. They are poor conductors of heat and electricity, with the exception of carbon. Carbon tends to conduct electricity much better. They tend to be brittle if they're in a solid form, which means if you hit them with a hammer, they're going to shatter. Just think about taking a piece of carbon and hitting it with a hammer, or silicon and hitting it with a hammer. Now the metalloids are located in the stair-step area of the periodic table. That's the area between the metals and the nonmetals. Generally, they have properties similar to metals and similar to nonmetals, depending on the conditions that they are experiencing at the time. And we mentioned that most of the nonmetals are gases. Gases tend to be diatomic, or two atoms of the same element attached to each other when they are in the natural state. They don't like to be by themselves. These seven are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Now, you can use the rule of 7 to remember which elements are gases. Starting with element number 7, which is nitrogen. There are 7 gases, and except for hydrogen, they form a 7 in the periodic table, as you can see by the blue line. 3 across and 4 down.